If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Evening, everybody. Welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, not to mention those darn good friends of York University. I'll be one of your three hosts this evening. Yes, party of three. My name is Paul Delaney, and we've got just north of me, hi Julie.
Hello.
And just down the road and round the corner from her, Sana.
Hi.
Yes, this is all north of York University tonight. Absolutely. We are broadcasting live, more or less, from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. And it is, of course, Science Night in Canada, where the lineup is entirely Canadian, starting with ourselves, York Universe. On to the classic episodes of Western World's most recent articles, or presentations, Quirks and Quarks, and, of course, Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, which, of course, is Tuesday morning, 1 a.m. Universal time at this time of the year. The York Universe production works in concert with our online public viewing program run by the Observatory team. Hi there, guys. It runs, of course, at the same hours as we do, from 9 till 10 o'clock local Toronto time. By all means, please point your favorite web browser to observatory.info.yorku.ca and follow the links to OPV, online public viewing. By all means, please join the chat there, and there'll be lots of wonderful archival images being shown to you this evening. Our broadcast is powered by and is in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you might have about our past shows, all 501 of them, or if you have suggestions for future topics, please send us a note at observe@yorku.ca. You can always connect with us on Twitter with our handle at York Observatory, or on Instagram with the handle at York U Observatory, and of course Facebook at Allan I Carswell Obs. All of our programming is free, but if you would like to make a donation, by all means please visit our website observatory.info.yorku.ca. We will be monitoring the chat room for any questions, trying to post a little bit of content. The weather outside is, well, we're in the path of thunderstorms. So guess what? The telescope is not open and everybody is hunkering down, staying well clear of those sort of flashy lightning bolts. But as I said, the observatory team is there answering your questions with archival imagery. So ladies, it's August. Can you believe that? Like, we're into the second week of August.
Time has no meaning.
Einstein would probably beg to differ on that point, but anyway, yeah, okay.
Yeah,
I don't know where half the summer's gone.
Yeah, that went by way too fast.
It just seems like yesterday that it was May. It always does that. May comes around, and I think all of us in the university sector at least go, because, of course, you've just survived the fall and the winter, and May is such a wonderful month, and you have like 3 million things planned for the next few months, and then, as we've just said, a blink of an eye later, it's August. And those 3 million things, there's probably about 3,000,001 that still need to be done between now and the end of August.
Yep.
It's so true, and for me, I didn't have May and June. It was just July.
Yeah, as you say, time really does whistle by. I guess that's a good thing, but on occasions, I really wouldn't mind it going slower.
Yeah, it was nice how it went by kind of fast when we were waiting for the first web data. But now I just kind of want it to pause for a bit.
This is true. And of course, we were all waiting for that fateful moment in June when the new domes were hoisted into place. We were all waiting for that. And now, it seems such a long time ago. I mean, in the rearview mirror, to say the least. Anyway, fingers crossed. And of course, Julie, next week you are the astronomer in residence up there at Killarney Park, right?
I am indeed, and I'm really excited, but also I have to have a bunch of presentations ready, and they're not ready.
And here's that time business thing again.
Right.
Well,
Don't think it's linear. They keep telling me it is, but I don't believe it.
you don't believe it. Hey, you will be able to ad-lib if the need arises, but you will be great next week. Dark skies, just in time for the Perseid meteor shower, or actually just after the Perseid meteor shower, I guess. But still, there'll be remnants of the Perseids for you.
Oh, I'm really looking forward to it. It's been too long since I've been under a truly dark sky.
Sounds excellent. So, Sana, when are you signing up?
Maybe next year.
Yeah, you've got to clear it with that boss of yours, right?
Yeah. I was thinking about when I should go because I really want to, but probably after I've finished the thesis.
Sounds like a very good plan. A quick little congratulations after the masters and before the PhD.
Yeah, take a nice little kind of break to just observe and have fun.
Absolutely. I'm sure Adam will give you a day or two off. I mean, yeah.
Yeah.
All right, enough of this little chit-chatting. Sana, would you like to lead the way to Mars, please?
Sure. So this is sort of not exactly this week in history, but just a few days ago, August 5th, 2012 was the anniversary of Curiosity landing on Mars. So Curiosity landed in Gale Crater near the base of one of the mountains in the crater called Mount Sharp. Gale Crater was kind of the perfect spot for Curiosity to land because one of the main mission goals for Curiosity was to look for evidence of water on Mars and also evidence of if Mars had been habitable in the past. So it wasn't necessarily looking directly for evidence of life on Mars, but just could life have possibly existed on Mars sometimes in the past. So Gale Crater was a good place to put Curiosity because there were tons of existing signs that water could have existed in that crater sometime in the past. So it was things like clays and sulfates that were in Gale Crater, which tend to form in the presence of water. So that's kind of suggested that water had to be flowing around there at some point. So like I said before, there was a ton of work done, or one of the main science goals for Curiosity was to look for evidence of water and evidence of habitability on Mars in the past. And one of its major breakthroughs of the Curiosity mission was that it did determine that Mars had been habitable in the past, likely for a period of millions of years. So it wasn't kind of a short little stint of habitability on the planet. It could have sustained life for a fairly decent amount of time. And one of the ways that it did this is that it found Curiosity kind of drilled into rocks using some of its instruments and could analyze the composition of the rocks, where it basically found some building blocks for life. So things like elements like oxygen and carbon and nitrogen, and even some organic molecules which are needed to support life. So it had found a bunch of interesting things in some of the rocks in Gale Crater, which did suggest that it is a kind of possibility that life did exist on Mars. In addition to studying the habitability on Mars, Curiosity also did a ton of work just generally investigating its environment. So things like the Martian climate and the Martian geology. It did a lot of work studying the groundwater cycles on Mars and studying clouds and the weather. Some of the things that it did to study the weather included the temperature, atmospheric pressure, and humidity on Mars and how those things changed over time with the different seasons on Mars. And one of the other interesting things that Curiosity did is it studied the radiation environment on Mars. And this is a pretty important thing to do, not just because you can do some interesting science with it, but because a lot of space agencies always kind of have in the back of your minds, like we're planning manned missions to Mars. So one of the hurdles in planning a manned mission to Mars has to do with being able to survive harsh radiation environments away from the Earth. So Curiosity has just been taking a lot of measurements about what the radiation field on Mars looks like, and could humans sort of be subjected to this and survive. And it turns out that the answer for shorter-term crew missions is that it is a manageable amount of radiation on Mars. So it is kind of plausible to have a short-term manned mission manned mission to Mars without exposing astronauts to a fatal amount of radiation. So it's always good. So overall now, 10 years later, after 10 years of science, Curiosity and all of its instruments are still functioning really well. So it's going to be able to operate for... the thing that it's planning on doing now is basically studying how the Martian climate transitioned from being habitable to the way it is now. And one of the things that it's going to be doing is it's going to be climbing the side of the mountain in the crater Mount Sharp. It's going to be going to a different area than it has been before, and orbiter images of this area show that it looks very different than the rest of the areas that Curiosity has been in before. So it likely has different minerals and things in this new area that it's going to, that'll help to kind of investigate a different era on Mars than it has been overall. So happy 10th birthday to Curiosity.
One thing that you forgot to mention is that here in Toronto, it landed at 1 a.m. in the morning. I personally thought that was terribly inconsiderate of it. I mean, you know, it was a really long night, that one, waiting for it, but I remember it so well. It was exciting. I mean, it was a real blow-by-blow descent. In fact, it was one of the really cool aspects of the descent. I mean, everything you said about what it's been doing for the last 10 years was fabulous. But all missions to Mars prior to Curiosity didn't have a lot of insight, so as to speak, as we were falling from orbit. There was a little bit of information, not a lot. Whereas with Curiosity, literally every major milestone had its own sequence of pings, and we knew as it was descending through the atmosphere how well the landing was progressing. And that was, to me, absolutely amazing. I will date myself here and go all the way back to the Viking landing in 1976. This was pre-internet. In fact, it was probably pre-both of you. But anyway, it was pre-internet as well. And as a consequence of that, even though I knew exactly when Viking was supposed to touch down on the surface of Mars, it took nearly 15 minutes before our local radio station had the courtesy to say, yes, Viking had landed on Mars. And that was terrible. So listening to Curiosity go down blow by blow to the surface was really fabulous.
I remember watching the Perseverance landing a few years ago. That was great seeing that.
And yes, we actually did get to see a lot of it, that's for sure.
Yeah.
We've come a long way in this regard. Yeah, as you also indicated, Sana, the spacecraft itself, or the rover, has really stood the test of time very, very well, with the one notable exception of its wheels. The wheels certainly have taken a little bit of a pounding. There's a lot of holes in the aluminum that's associated with the wheels, not to the point where the mission is being compromised, but certainly some of the gashes in the wheels look really nasty, and they have taken some significant pains now to ensure the terrain that Curiosity rolls over is as smooth as is practical, so that they do eke out as long a mission lifetime as they possibly can.
I've seen some of the pictures of the wheels. They look beat up. For Curiosity.
Was Curiosity the one that because like OPV and Spirit had like pretty beat up wheels too?
True.
Did they use those lessons on Curiosity, or was that too soon after those two?
That's actually a rather good question. I would bet that they did learn from it. The problem, I think, that arose out of Curiosity is that, unlike Spirit and Opportunity, Curiosity is like 4 times the mass. And so it was a significantly heavier vehicle. And that, I think, surprised the handlers of Curiosity, that the wheels, even though they had been scaled up from Spirit and Opportunity, I think just took more of a pounding because of the mass of Curiosity compared to Spirit and Opportunity. As I said, it literally is 1,000 kilos, Curiosity, whereas Spirit and Opportunity came in at about 250 kilos.
Right, because Curiosity is like SUV size.
Yeah, small SUV. That's exactly right.
He's a big boy.
Yeah.
I was kind of shocked the first time I actually saw a picture of Curiosity like sitting beside someone or one of those the scale models of Curiosity. I didn't realize how big it was.
Yes, yeah. There's a pretty classic image from NASA where they've got a replica of Pathfinder Sojourner, well, actually the Sojourner rover, Spirit or Opportunity, doesn't matter, the MERs, and then Curiosity, and a couple of technicians there. It really is quite revealing. I mean, Sojourner is like a microwave oven on wheels. That's how small it was, and then within literally a dozen years, you've got Curiosity, and it's, as Julie said, a small SUV. Yeah. Great
I guess
stuff.
in my mind, they're all Sojourner sized.
Yeah.
You kind of like, yeah, that was my first rover. I kind of stayed there in my mind.
Quite correct. First rover on Mars. No question. Back in 1997. Okay, well, sorry.
Yeah, that's kind of more the size that I would have expected is like a smaller one like that, but sorry.
Well, that's okay. Perseverance, Curiosity, yeah, those are quite substantial in size. But Sojourner led the way.
Go big or go home?
I guess somebody did. And they wrote the check too. Okay, let's carry on with the Mars theme here, but I'm going to take us all the way back to August 7th. Well, it's not all the way back, but August 7th of 1996. This was the day that President Clinton introduced a NASA press conference. Yes, you heard me right. The President of the United States was introducing a science presentation from NASA led by Chris McKay, part of a NASA team that had been investigating a Martian meteorite. And they basically were claiming at that point in time that they had found evidence within this meteorite of past life on Mars. So this was a fairly astounding assertion. It was a peer-reviewed paper, by the way. We're not talking about, we just sort of scribbled this down last weekend and we're bringing it out now because it sounds good. There was a lot of years of effort into the analysis of ALH 84001. It was a meteorite that was picked up in the Allan Hills area of Antarctica in 1984, and it was actually the first meteorite that they were cataloging that particular year, hence ALH 84001. It is the oldest of all of the Martian meteorites that are on planet Earth. Comes in at about 4.1 million years old, so it formed on Mars that long ago. It was ejected from the surface of Mars, if memory serves, somewhere in the vicinity of 15 million years ago, give or take. So something slammed into the surface of Mars with sufficient energy, sufficient velocity that it shattered a portion of the surface, and ALH 84001 was ejected at escape velocity from Mars. Wandered around the inner solar system until about 14,000 years ago, when it got caught by the Earth's gravitational field and dragged it down to Antarctica, waiting to be picked up in 1984. And so the analysis of this particular meteorite had three particular lines of evidence that suggested to McKay and company that there had been past life on Mars. Not going to get carried away with what those lines of evidence were, but the bottom line to it is 25 years later, this poor little meteorite, it has been subjected to cruel and unusual punishment, has been analyzed literally to death around the world, and continues to be a source of great interest in the meteorite and Mars communities. The general consensus is that the lines of evidence that Chris McKay and company put forward really point to chemical activity rather than biological activity. And as I keep telling my class, where chemistry stops and biology starts is a really thin line. And a lot of things that biological systems are able to generate can also be generated by chemical interactions. And we know now that, of course, the Martian surface is a very chemically reactive surface. It is rich in oxidizers, perchlorate, and so on. Lots of things can happen chemistry-wise within the surface environment of Mars. And so the general consensus is that it's chemistry that is happening on Mars, not biology. but it's a consensus. There are still many people who are writing papers who believe quite fervently that at least one line of the evidence originally portrayed by Chris McKay and company is better supported by a biological explanation rather than a chemical explanation. Basically, the alignment of magnetite crystals within the subsurface of ALH 84001. I'm not enough of a geologist to weigh in one way or the other, but the sheer fact that so many papers over 25 years of investigation continue to be generated to this day tells you that the Martian environment is a complex situation. Nonetheless, it was an interesting press conference, and as I said, it was a peer-reviewed paper. The lines of evidence were quite strong, and it certainly got people thinking. But as I said, the consensus is basically that it's chemistry, not biology. It was a very important day, shall we say, in Mars exploration, and it reminds us that some of the most interesting aspects of Mars investigations still happen here on Earth. These meteorites that come to ground here are able to be examined by some of the best systems here on our planet, something that we can't send with Spirit, Opportunity, Curiosity, Perseverance. And of course, why NASA and the European Space Agency are seriously planning a sample return mission at the end of this decade, well, actually the beginning of the next, to be able to bring all those samples, and I know Sana is going to tell a little more about this afterwards, but more of those samples back here to Earth where we can subject them to more cruel and unusual punishment from a analysis perspective. At any rate, 1996, August, the day that perhaps many thought had revealed life on Mars.
I remember reading Terence Dickinson's article in his weekly column in the Toronto Star about that meteorite.
Yes.
And I also wrote an essay for my English class about it.
Wow.
I
dare say your prof was going, what is she talking about?
Well, I don't know. I was told to write a whatever type of essay, and I could choose whatever I wanted to write about. So
you did.
Meteorites it was.
Meteorites are very neat. There's no question. And where you, of course, hang out a lot at the Royal Ontario Museum, a fabulous collection of meteorites.
Oh, absolutely. And the curator, Dr. Kim Tate, is involved in the planning of the sample return mission.
Oh, excellent.
From Mars.
Wow.
So, and she was involved also, or is involved also in OSIRIS-REx. So when those samples come back, some of that work is going to happen right here in Toronto.
Excellent.
Which is awesome.
Oh, really awesome. I agree.
Yeah.
That's for sure. Now, Mars is always, I think, on everybody's radar. And when you have interesting results coming out, be they, correct interpretations or incorrect at that time based upon further information, it's really great stuff. One of the papers that came out in the early part of this century that sort of bolstered McKay's team's analysis, but didn't come out and say that it was life that was in the meteorite. But the carbonate modules that were in ALH 84001, it was shown that they formed in a watery environment at temperatures in and around 20 degrees Celsius. So 4.1 billion years ago, Mars was distinctly habitable. In fact, it was more habitable at that moment in time than Earth was. Earth had not yet managed to generate liquid water on the surface. We're a big planet, and we were still a little bit on the hot side. Mars had cooled because it's smaller, and the atmosphere had outgassed. Water was present on the surface, and ALH 84001, portions of it were formed in that liquid warm water environment. Moving right along here. Julie, I think you want to take us away from Mars.
Yeah, I'll take us away from Mars. You know, I feel like we're gonna head back to Mars later in the
You've
show.
been reading ahead, huh?
I have this feeling we're not going to go too far from Mars. So August 12th, 1977, marked the launch of the. Now I'm not sure if people like pronounced all these letters or put them all together. It was either HEAO-1 or the HEAO-1 satellite. Which stood for High Energy Astronomy Observatories. This was the first of a series of very large scientific payloads that were launched by NASA starting in 77. The first one surveyed the X-ray sky over the 0.2 kiloelectron volt to the 10 megaelectron volt energy band and provided nearly constant monitoring of X-ray sources near the ecliptic poles until January 9th, 1979. There were also some more detailed studies of a number of objects that were made, and those observations typically lasted 3 to 6 hours. There were 4 experiments on board. The first one was the Large Area Sky Survey, or LASS, and that one concentrated in the 0.25 to 25 kiloelectron volt band. The Cosmic X-ray Experiment, which had 6 separate proportional detectors at low, medium, and high energies. The Modulation Collimator, that worked from 0.9 to 13.3 kiloelectron volts, and the Hard X-ray / Low Energy Gamma Ray Experiment, and that had 7 scintillator detectors, again at low, medium, and high energies. And there were quite a few science highlights that came out of this mission. These included a complete flux-limited high galactic latitude survey, the measurement of the X-ray background between 3 and 50 kiloelectron volts, a comprehensive catalog of X-ray sources, one for each of the 4 experiments, several hundred optical comparisons and source classifications based on X-ray source positions, monitoring variability of a variety of objects from active galactic nuclei to X-ray binaries, studying aperiodic variability in Cygnus X1 on timescales on a few milliseconds, and the discovery of the first eclipse seen in a low-mass X-ray binary. So, go little satellite go. And a satellite I'd never heard of till when I was doing my research this morning.
The 70s ended up being a bit of a bonanza year for a variety of differing astronomical satellites. I mean, we started launching them in the 60s, but when all was said and done, their maturity wasn't very high. But in the 70s, that was when we really got down to business, shall we say, and capitalized on low Earth orbit, being able to launch a variety of satellites to investigate wave bands, of course, that were not detectable here on the surface of the Earth. The Earth's atmospheric windows precluding all sorts of good stuff, although I must admit, stopping X-rays from coming through to the surface, that's probably a good thing. But
yeah, I'm going to support that.
But X-rays, ultraviolet, and so on, though gamma rays, all of that good stuff in low Earth orbit opened up a variety of fields in astronomy, and we began to realize that this was an arena we needed to exploit, usher in things like Hubble Space Telescopes and James Webb Telescopes in the ensuing decades. But the 70s, in my mind, is where we really experimented with great success with astronomical satellites. And we pronounced it HEAO, by the way.
Thank you.
Not a problem. Okay, Sana, where are you taking us?
To 1977, August 12th. This is
Same day.
Yeah, I was going to say, exactly.
which was, okay, so August 12th, 1977, it was the first free flight of the Space Shuttle Enterprise. So Enterprise was the first orbiter that was made as of the Space Shuttle program, but it was actually designed as a test aircraft, not as a spacecraft that was going to do normal missions like other space shuttles did. But it was just to sort of test out the space shuttle and try and characterize it so that that design could be used to do actual missions to space.
Flying brick. I'm sorry. Excuse me.
A very important flying brick.
Yeah, I agreed, but still.
Yeah. Enterprise itself was quite different to a lot of the later models of the space shuttles, simply because it just wasn't designed to normal space shuttle activities. So it didn't really need a lot of the systems that other space shuttles would need. So just for example, the fuselage was quite different, the thermal protection systems were different, and it also didn't have a ton of equipment that the other space shuttles had, like radars or main engines even. So Enterprise was rolled out on September 17th, 1976, after which it had a few captive flights. And I think this is really cool. I've seen pictures of the space shuttle attached to a modified Boeing 747, which is really cool. So they would just kind of do these captive flights where they kept Enterprise attached to a 747 and did some tests with it in the air, but it never actually detached from the shuttle carrier aircraft, as it was called. And these just sort of did some initial tests of how the shuttle would be able to act when it was in the air. And then August 12th, 1977 was its very first free flight. So it actually detached from this modified Boeing 747 and flew on its own, just landing on its own after detaching. This was of course a crewed flight because somebody had to be on the space shuttle to land it. It included astronauts Fred Hayes and Gordon Fullerton acting as the commander and the pilot, respectively, on the mission. The pair of aircraft detached at an altitude of about 20,000 feet, and then the Enterprise just sort of glided down to landing on a runway a few minutes later, completing its first free flight. After this, Enterprise did about 4 more of these free flights, which were basically just to again, test out the systems. So how does this thing fly when it's in the air? And all of this information would be used to sort of make any needed changes to the space shuttles that would later be used to fly in space. So I think that this is really cool. I saw a video of the 2 aircraft detaching in the air, and that was really cool. But just another interesting thing I read about this is the name of Enterprise. I seem to kind of remember talking about this at some point, but Enterprise was initially named Constitution, but Star Trek fans kind of convinced NASA to change the name to Enterprise after the show. So, yeah, lots of interesting things about the Space Shuttle Enterprise.
It's an iconic image, in fact, with the Enterprise rolled out onto the runway, and all of the Star Trek, William Shatner was not there. Almost all of the original Star Trek crew were clustered around, and the Gene Roddenberry, the administrator for NASA. It was a good day, and it was very fitting that Enterprise ended up the name, because, of course, the show Star Trek, as well as NASA, have inspired so many engineers and scientists over the decades. So, yeah, it was a highly appropriate name selection.
It's better than Constitution.
So much better than Constitution. We named our awesome space shuttle after a piece of paper.
I dare say the folks south of the border thought that was a pretty good plan. But I agree. There's more Star Trek fans out there than there are south of the border folks. So no question. Star Trek forever. Yeah, but it really was a flying brick. I mean, I kid you not. I mean, it was a glider, and almost every pilot who commented on it said it handled great. It was really beautiful, but it really was a flying brick. So Fred Hayes and Gordon Fullerton very courageous in my mind to fly that down. I'm sure they've flown it a million times in the simulators. But Fred Hayes, of course, was from the Apollo 13 fame as well. So he had his fingers in a lot of the excitement there in the 1970s. Julie,
Yes.
Speaking of NASA,
staying on August 12th, but different year. Apparently, a lot of things happened on August 12th in the past.
it certainly did.
Yeah, August 12th, 2002, Frederick D. Gregory was sworn in as the first African-American deputy director of NASA. So he is a former U.S. Air Force pilot, a military engineer, a test pilot, and also a former astronaut. He also, after serving, closer to the end of his tenure as deputy administrator for a brief time, was acting administrator in 2005. He was born and raised in Washington, D.C., in a very accomplished family. And his accomplishments, he did not disappoint his family. But just to give you an idea, his father, Francis, was an educator and assistant superintendent for D.C. public schools and the first Black president of the D.C. Public Library Board of Trustees. His mother, Nora, was also an educator and took over for the Board of Trustees after Francis died, I believe it was in 1977. And she became a strong advocate and fundraiser for the library after that. His uncle was Dr. Charles Drew, and he was a physician, surgeon, and researcher who developed improved techniques for storing blood for transfusion and developed large-scale blood banks during the Second World War. His great-grandfather was James Monroe Gregory, who was a professor of Latin and the dean at Howard University and worked to educate and aid escaped slaves during the American Civil War. So, he had a few people to look up to and take after.
Indeed.
Right?
Yeah. Wow.
So he was selected as an astronaut in January of 78. His technical assignments were many, one of them including being one of the Capcom during the Space Shuttle Challenger disaster. He flew on 3 space shuttle missions. He was a pilot on STS-51B from April 29th to May 6th of 85. He was the space shuttle commander on STS-33. That was November 22nd to 27th of 89. And he flew again on STS-44. That was November 24th to December 1st, 91. And that made him the first African American to pilot and to command a space shuttle. Before serving as deputy administrator, he was associate administrator for the Office of Safety and Mission Assurance from 92 to 2001, and he was the associate administrator for the Office of Spaceflight from 2001 to 2002.
A busy guy, to say the least.
Indeed.
So the question, pardon me if you answered it, do you know how long he stayed as the deputy administrator?
He was there from August 2002, and he resigned, I believe it was September 2005.
Okay, all right, so he was there for 3 years. Okay, right through the Columbia loss, too.
Yeah.
Yeah, so, yeah, big era, shall we say, the early part of the 21st century. And, of course, that was in and around the time when they cancelled the shuttle program there in 2005. So he was a part of important history for NASA and, of course, very accomplished astronaut as well. So, yeah, wow.
Indeed. Yeah. Talk about a career.
Yes, indeed. Yes, indeed. I dare say he's had a lot of public speaking gigs since then.
I imagine so.
I would imagine so. That's for sure. All right. In space history, because it's on here, And circling back, whichever, to the theme of, yes, there is that date, August 1977, the discovery of the moon Deimos. Of course, dread and in Greek mythology, Mars, a lot of war, sort of went hand in hand. Has two tiny little satellites, and the first Deimos was by Asaph Hall III, no less, on August 12th, 1877, not 1877. Fast forward 6 days, by the way, and that's when he picked up Phobos, which is rather interesting because Phobos is actually bigger than Deimos. But nonetheless, he found Deimos first. He was observing from the U.S. Naval Observatory here in Washington, D.C. And, of course, as I said, these two satellites, really tiny. I mean, we're talking about, on average, 7 kilometers in diameter. That's how small Deimos is. So sharp-eyed Asaph Hall, my gosh, no light pollution in Washington downtown, I guess, at that point in time, because that was a challenging observation to be able to see Deimos, but he succeeded in doing it. Deimos swings around Mars very rapidly, not as rapidly as Phobos, but Deimos has an orbital period of about 30 hours, just a touch over 30 hours. As you can well imagine, with an object that small, there's not a whole lot of real estate to talk about. Yes, it's heavily cratered. The density of the moon, we think, is a little over that of water, around about 1.5 grams per cubic centimeter. Its appearance is smooth with a few craters. It has almost like a pumicey feel associated with it, or not feel, appearance. And as I indicated, very low density. It's more or less a C-type asteroid, so it's rich in carbonaceous material, at least spectroscopically. That's what it's telling us, because, of course, we haven't picked up any material from its surface at this point in time. The biggest challenge associated with Phobos and Deimos is associated with where the heck did they come from? They are both in near circular orbits in the equatorial plane. That's a really specific location to end up, and that sort of implies that maybe, just maybe, these two tiny little satellites formed in situ with Mars, or at least formed as a result of some sort of collision with the Martian surface, throwing the material up into the equatorial plane. Of course, the competing and the obvious thought is maybe they were captured asteroids. Mars is on the inner edge of the asteroid belt, and even though it's got a pretty tiny gravitational field, it's only about half the diameter of the Earth, maybe it was just enough to snag a couple of rogue little asteroids. We really don't know. It's one of those big mysteries at this point in time. But as I said, a tip of the hat to Asaph Hall III for actually being able to see these two tiny little satellites in August of 1877 from the U.S. Naval Observatory.
Do you know how big the telescope that they used for this was?
I do not know, but telescopes back in that era were not known for their size. I would say that we're probably talking about maybe a 10 or 12-inch refracting telescope. Those were the telescopes of choice for doing planetary observation. But I don't know. I will look that up for you, Sana, but it would not have been very big.
So must have had very good skies.
Well, therein lies the point. And he was a very talented observer. That also helps, that's for sure. Reminds me of somebody else on the line. Folks, you're listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan Carswell Observatory here at York University in Toronto, Ontario, Canada. Julie, Sana, myself, Paul, keeping you company this evening, Science Night in Canada. We've just wrapped up this week in space and astronomy history. Almost took the entire show. We really do ramble, don't we? Sorry about that. A reminder, this coming Wednesday is our Teletube Wednesday. The observatory here broadcasts on Wednesday evenings via YouTube, 7:30 in the evening. I'm not certain. Sana, is there anything special happening this Wednesday evening?
Maybe. Hold on.
I know we've got the Perseids on Saturday, but I wasn't sure whether or not there was anything unusual other than our regular presentation. Pick a theme and field questions.
Let me just pull up the schedule. I know that there's something going on with the DDO.
That's on Saturday. That's a celebration of the Perseid meteor shower.
Okay, so it's going to be 10th on Wednesday. I don't see anything interesting on the schedule.
Well, no, nothing special, shall we say.
Yeah.
So
Yeah.
anyway, YouTube this coming Wednesday for our Teletube activity. As we've indicated, the Perseid meteor shower is coming up this weekend. It sort of peaks on Friday night, but of course, a few days before and a few days afterwards, the Perseids are always a good show. Lots and lots of good fireballs, and despite the fact that there's going to be a bright full moon on Thursday evening, just to add a little bit of complication, I would still strongly recommend people go out and observe Friday night and Saturday night if you have the chance. The Perseids this time of the year, nice and mild. Yeah, this is a good opportunity. And while you're in the neighborhood, you can have a quick look out for Saturn, which is at opposition on the 14th, so that's on Monday. Saturn will be rising over there in the east, southeast particularly, as the sun is setting. So give it an hour or so, around about 10 o'clock, you should be able to see a pale yellow dot there on the southeastern horizon, nice and bright, and that is the planet Saturn. Okay. Sunner, we've got the Mars theme going here. Do you want to bring us up to date on Perseverance, please?
Sure. So this is a bit of an update on the sample collection and general sample return mission that's planned between NASA and ESA. So part of it is that the Perseverance rover has now picked up 2 more samples. They were announced last week. I'm not sure when they picked them up, but has added 2 more samples to the samples that will hopefully be returned to the Earth in the next decade, probably. So like you were talking about before, there is a joint mission between NASA and the European Space Agency to do a sample return from Mars to the Earth. This is going to be the first sample return done from Mars. There have been some sample returns from the Moon, but it's much, much harder to do a sample return from Mars. And the Perseverance rover is basically the first step in this mission. It landed in Jezero crater a couple years ago, and it's been collecting samples periodically while it's been traveling through Jezero crater ever since then. It's basically storing these samples in the belly of the rover. And at some point, once it's finished its sample collection and it's found a suitable location, it will be dropping off these samples, which will then later be returned to the Earth. The sample return mission is still sort of in the planning stages, and this week it underwent kind of another massive change. The original plan was that that Perseverance would kind of deposit these samples somewhere, and then later a rover built by the European Space Agency would go and collect those, bring those over to a rocket, which would then launch the samples up to a Mars orbiter, which would then return them to the Earth. But they ended up changing the plan a little bit. I'm not 100% sure what caused this change, but they changed it just a little bit so that now Perseverance will be bringing the samples over to a small rocket that will launch the samples to an orbiter and then bring them to the Earth. So they've kind of cut out that second rover that was supposed to collect them and then over to a rocket. And just as a backup in case needed, they will be also having 2 helicopters, kind of like Ingenuity, that will be able to assist in that sample collection if needed. So I was going to give a little spiel about why these sample return missions are important, but it's kind of like you were talking about earlier about the Meteor from Mars, which is just that it's such an important thing to do because we can't really analyze rocks properly on Mars because there's a limited amount of equipment that can be brought over on these rovers. But anyways, so it's very exciting just because we will actually be able to do in-depth analysis now of rocks from Mars. But yeah, anyways, Perseverance recently picked up samples number 11 and 12, which are both from sedimentary rocks on Mars. And the reason that these particular samples were picked is just because they could have biomarkers that show evidence of past life on Mars. Many of the samples that have been collected so far are all come from sort of volcanic rocks. So it's Perseverance sort of shifted now from collecting rocks associated with volcanism to collecting rocks that actually could have biomarkers or signatures of life on Mars. So in addition to the 12 sample tubes that it's already filled, it has also sealed 3 more of them. One of those tubes just contains Martian air, and then the other 2 are these things called witness tubes, which are just designed to help scientists who analyze the samples determine if there were any sort of contaminants that come from the Earth that could have gotten into those samples. So 2 of these witness tubes are sealed as well, and in total there are, I think, 43 of these tubes that will be collected and returned to the Earth in this sample return mission. 38 of them will be actual samples from Mars, and then the other few will be things like the witness tubes. So again, mission is still in the very early days of planning, and it's likely the mission will be launching to Mars to pick up the sample in about 2033 at the earliest, but probably later. If we know anything about missions, they get delayed a lot, so I'm betting on later than 2033, but still very, very exciting.
The main reasons that they changed were there were 2 reasons why they cut out the Fetch rover. One, obviously, cost, but secondly, Perseverance is doing so very well at this point in time that NASA is projecting that it will still be fully operable in and around the time of the sample return mission. And so if that is the case, obviously it's one less headache for everybody to worry about. If Perseverance can sort of just drive on over to the ferry rocket that is sitting there on the surface, it just is so much easier for the whole system. But they're hedging their bets. They have got those 2 little sort of Ingenuity helicopters on standby in the event that, I don't know, Perseverance gets a flat or something like that and can't quite make it there.
Very, very exciting.
No question in the world.
Yeah.
26-inch refracting telescope, by the way, is what Asaph Hall used to find Phobos and Deimos.
Thank you.
Yes, yeah. Took a little bit, but yeah. Nice refracting telescope. Definitely what you want to use for planetary observations. No, Perseverance and the sample return mission, everything about Mars is really very, very exciting. But let's face it, Julie, not to be outdone, there are planets in the outer solar system that are begging for exploration, right? Julie? Julie? Hello?
Sorry, forgot to unmute myself.
Oh, there you are.
I was about to launch forth, but okay, I'm glad you're back.
Realized when you were like, Julie, hello. I didn't unmute myself. Okay, yeah, I just want to add one little thing to the Mars thing before we move on to the outer solar system. We did, if you go to the ROM, Royal Ontario Museum YouTube channel, you should be able to find a session with Dr. Kim Tate that we did maybe a year and a half ago, maybe 2 years ago. I want to say a year and a half ago, about the Mars sample return mission, and talking a little bit about like the planning, what those those tubes that they were collecting them in, like what the designs of those had to be like. Because, they have to survive on the surface of another planet at least a decade.
And then some, yes.
And then some, which is a little wild. So if you have interest in like learning a little bit more, you can head over there. Okay, but let's head out a little bit further than Mars in the time that we have left. To a possible mission to Neptune. And this is not a NASA mission. This is a mission that is being considered by China. So China is considering a nuclear-powered mission to Neptune, and this is a mission that would explore the ice giant as well as its largest moon, Triton, and some of its other satellites and its rings. So a paper about the proposed mission was published in the journal Ciencia Sinica Technologica.
Easy
it was
for you
led.
to say.
Not really. The study was led by Guobin Yu, a researcher at the School of Aeronautics at Beihang University and the Department of Science and Technology and quality at the China National Space Agency, or the CNSA. And it was conducted by researchers from the CNSA, the Chinese Academy of Sciences, the Chinese Atomic Energy Authority, and the China Academy of Space Technology, and multiple universities and institutes. The mission hopes to shed light on Neptune's interior structures, including diamond rain. The role in the formation, Neptune's role in the formation of the solar system. So the composition includes large amounts of gas that were part of the protostellar nebula from which the solar system was formed, and its position indicates where planets formed and have since migrated to their current orbits. Looking at Triton, which astronomers suspect is a planetoid flung from the outer solar system and captured by Neptune's gravity. Its arrival is also thought to have caused a shakeup with Neptune's natural satellite, causing them to break up and coalesce to form new moons. It's also theorized that Triton will eventually break up and form a halo around Neptune or collide with it. Basically, the study of Neptune's, its satellites, and its orbital dynamics could provide answers to how the solar system formed, evolved, and how life began. Sending missions to deep space is hard. Difficulties include launch windows, power supply, communications, and the last mission to Neptune was Voyager 2 in 1989. There was a proposed NASA mission to Neptune, but it was not assigned priority in the Planetary Science and Astrobiology Decadal Study of 2023 to 2032, because it was passed over for a Uranus orbiter and probe, which is another understudied planet. So if another space agency wants to study Neptune, hooray! Design considerations, the team determined that the source that would be safe and reliable for providing electricity for no less than 15 years would need to be radioisotope thermoelectric generator. And basically, this is a nuclear battery, similar to what Curiosity and Perseverance rovers use, that convert heat energy from the decay of radioactive materials into electricity. And proposed instruments include an atmospheric probe for studying the planet's interior, and a Triton penetration probe that would examine the moon's crust, and a complement of smaller satellites like CubeSats or nanosatellites to be deployed along the way to explore the main belt asteroids and Centaur asteroids. As for the mission profile, the team recommends the mission be a probe in polar orbit to achieve the scientific goals. They also recommend increasing the probe's flight speed as much as possible in the early stage of getting there and decelerating to achieve orbit around Neptune. They suggest a launch around 2030, which would allow for a gravity assist with Jupiter and an arrival date of 2036. There are a bunch of other launch opportunities in the late 2020s, early 2030s, which would have the probe arriving at Neptune before 2040. And the scientific objectives would be internal structure and composition, magnetosphere and ionosphere, moons and rings, and the populations of Trojans and Centaurs, which are small asteroid families that share the orbit of Neptune.
When you think about it, we got to Uranus and Neptune in the mid to late 80s within literally 20 years, within 30 years of the development of the space programs. And here we are talking about nearly 50 years later before we're going back. Oh, my gosh. Okay, we're at the top of the hour, ladies. So, gotta go. Thank you for joining us tonight. You've been listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan Carswell Observatory here at York University in Toronto, Ontario, Canada. Sana, Julie, myself, Paul, been keeping you company tonight. Of course, it is Science Night in Canada. Please stay tuned for classic Western worlds. On to a new episode of Quirks and Quarks, not to mention Science for the People. We'll see you, I guess, 2 weeks' time.
From AFM
Cheers.
Radio, the broadcast service of
Good night.
Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.